So, next one. Second, integral sin x to the power of n dx, where n is a integer, where n greater than or equal to 2, positive integer. Let us suppose in is equal to integral sin x to the power of n dx. This we can write integral sin x to the power of n minus 1 into sin x dx right now. It does not make any difference. This is the first function, this is the second function. By parts we have to do. Sin x to the power of n minus 1 integral sin x dx minus integral d by dx of sin x to the power of n minus 1 integral sin x dx and whole dx. Integral of sin x is minus cos x. So, minus sin x to the power of n minus 1 cos x and minus derivative of this one is n minus 1 into sin x to the power of n minus 2, sin x derivative is cos x, integral of this one is minus cos x dx. Now, let us simplify. This we can write minus sin x to the power of n minus 1 cos x and minus take out common, minus into minus plus n minus 1 common integral sin x to the power of n minus 2 cos square x dx. Now, this cos square x can be replaced by 1 minus sin square x. We know cos square x is equal to 1 minus sin square x. So, this we can write now minus sin x to the power of n minus 1 cos x plus n minus 1 into integral sin x to the power of n minus 2 into 1 minus sin square x dx. Now, this we can write minus sin x to the power of n minus 1 cos x plus n minus 1 times integral sin x to the power of n minus 2 dx and minus n minus 1 integral. So, now this into this sin x to the power of n minus 2 into sin square x, n minus 2 plus 2 sin x to the power of n. So, sin x to the power of n dx means again same integral appears, that is in. So, we get in is equal to minus sin x to the power of n minus 1 cos x plus n minus 1 into this can be written in minus 2, this is minus of n minus 1 in. So, this one and this one can be written in minus 2 and in. Now, bring minus n minus 1 in this side. So, in that becomes plus nin and minus in minus sin x to the power of n minus 1 cos x plus n minus 1 in minus 2. Here in cancel. Therefore, in is equal to reduction formula minus sin x to the power of n minus 1 cos x by n plus n minus 1 by n in minus 2. This is the reduction formula. But how long does it continue? So here one thing we can remember, note we can remember, note, if n is even after successive reduction, we get I naught. I naught is equal to, that is integral sin x power 0 dx. So we get x. If n is odd after successive reduction, we get I1, that is integral sin x dx, which is equal to minus cos x. Next reduction formula, integral tan x to the power of n dx. So now let In is equal to integral tan x to the power of n dx. So this can be written integral tan x to the power of n minus 2 into tan square x dx. Now this tan square x can be written, tan square x is equal to secant square x minus 1. So this is equal to tan x to the power of n minus 2 into secant square x minus 1 dx. So this we can write integral tan x to the power of n minus 2 secant square x dx minus integral tan x to the power of n minus 2 dx. Secant square x is the derivative of tan x, f of x to the power of n into f dash x dx, f of x to the power of n plus 1 by n plus 1. This is tan x to the power of n minus 2 plus 1 by n minus 2 plus 1 minus in minus 2. So this is equal to tan x to the power of n minus 1 by n minus 1 minus in minus 2. Therefore, in is equal to tan x to the power of n minus 1 by n minus 1 minus in minus 2. Now, note write down. Let us write note. First note, if n is even after successive reduction, we get I naught, means integral dx, that is x. If n is odd after successive reduction, we get I1 integral tan x dx, which equal to log mod secant x plus secant x